These are traditional manual hand pump that is very common in the rural areas, villages, hamlets, and so on and so forth. So we have tried to make it a smart one by integrating some sensors to it, and also integrated our board called the RUWATRONIK board, which acts as the IoT platform. So if you can come closer here, you can see what we did here. This is the flow control. And of course, a primary concern here is the issue of security and vandalism. So if you check, you can see there are no wires, no single wires here. So everything have been integrated in such a way that there's no access to any of the external wires. So this is the flow meter, and this is a piston. You know, the piston that pumps the water. So this is actually a brand new pump made in India. If you can come closer here to take the company's name, India Mark II deep well pump made for Christo Doga and Co. somewhere in Kano, what have you. So this we purchased in day market in Abuja here. And then our job now is to create intelligence in it in such a way that it can be remotely monitored. So all this we have checked. You know, we looked around and we consider where is the best place to put batteries to avoid contamination of water. We thought of putting batteries here, but the issue is that there's direct contact with water here. There's an explosion of lithium-ion battery that could cause some health hazard. So we thought other places where we could put a box without it being vandalized, which is a primary concern here. We finally came up with a solution, and that solution will be attaching over here. We're going to retrofit another box close to this very part, and we're going to fit a solar panel over here because there's a requirement for the battery to last for at least 3 years. The two are making us last for at least 5 years. Putting a small solar panel here to charge up a battery, and then we could use a boost converter, or we can use a buck converter. So it's a flexible design, which gives us that flexibility. Absolutely. So a box will be coming in here, of course, made up of metal. So you don't have access to the box. Batteries are inside there, the sensors, and so on and so forth. And again, we'll be adding some other intelligence here to be able to know the state of pump itself and the state of the machine. So we'll be adding some accelerometer as well to the handle here, which we'll show to you. And also that will enable us to know the efficiency of the pump. Maybe after 2, 3, 4, 5 pump, water comes out here. That means that the pump, the red pump here, that will be inside the well is functioning very well. Or maybe after 20 pumps before water comes out, that means that the pump is about to break down. And then we can alert you through our application that will do the remote monitoring. It comes under what we call predictive maintenance and so on and so forth. So what we did was that to pass this wire, especially through this very pipe, obviously for security reasons, so nothing can be vandalized. So it's coming out here, and as you can see, this is where the wire comes out. See, this wire is waterproof. You know, that's the flow meter. So this wire now will come through this hole. There's a hole over here. To come through this hole to a secondary box, we attach another box here, and then at the same time, we're going to put accelerometer on this very handle here. So we know when you're pumping, when you're not pumping, the productivity, the efficiency, and everything. This we'll try to demonstrate, okay? So right now, we're going to bring the box. Basically, this is a box we have made. So the box contains the batteries here, it contains some of the sensors. As you can see, the hole over here. We'll be sensing some environmental conditions. We'll be also streaming climate data, humidity of the air, temperature of the air, luminous intensity, the pressure. The whole essence is that we'll stream extra data, you know, that will be of use, maybe for farmers, for climate change, which goes hand with water and sanitation as part of the SDG. So we'll be streaming data to monitor climate change as well. So this is the box over here, and that will let him try to retrofit it. We can come closer to see us fitting it. So basically, yeah. So over here, so this is going to look. It's going to look this way with a bolt over here. So there's nothing. We're not welding anything here. So it's going to reduce the cost of retrofitting. Just your normal bolt that's been existing here. That's one of the bolts here. This is why that gives us the utilization of water. It gives us the precise liters being used on a daily basis. And so it comes over here. And you can see the wire coming over here. From over here, that's it. The cover covers here. So this is a solar panel that will be charging the battery, absolutely. And it helps actually prolong the lifespan of the battery, because 3 years is actually a lot of time, and even at 100 milliamp hour is quite a lot. So this will actually augment the capacity of the battery, that this can last as long as even 5 years, using just small tiny solar panel, very, very tiny, cost effective. And the good thing about that is that such solar panels as this are frameless, no metal, so it's not in high demand. Nobody's going to buy it from anybody if it is stolen. It's basically a specialized solar panel, simple as that, absolutely. This will can increase as time goes on. We can actually add additional pole to make it bigger or what have you. But for this instance, this is actually okay. So you have your flow meter here, you have your solar panel here, that's the energy system. You have your board here, which will open up to show you your batteries at this very attachment. Here, this attachment, the box will have retrofitted. Also, made in Kuje here at 2D4Pi Hub. They took part in the design of this very box, and the welding and everything was done right here in the hub. So we're going to add an accelerometer, as I mentioned, and that will monitor the pumping, how efficient the pumping is done. And then with this, you can relate data with AI and ML. We can do a lot of predictions, especially when it comes to maintenance, when it comes to utilization, and also project monitoring and evaluation. This is your pH sensor. It's a digital pH meter. It will be incorporated as well. That's number one. Here is a thermometer. We'll be measuring the temperature of the water coming straight from the borehole. Very important. So we are using a stainless steel. As you can see, it is stainless steel protected to make sure it doesn't affect the quality of, it doesn't affect the quality of water. So this will be here. Then this is the turbidity sensor. This shows the cleanness of water. So we can actually measure water quality, which is very, very important as well. You want to be sure there's no underground pollution of the water. You want to be sure that everything to do with water is very clean and what have you. So this gives us the cleanness of the water. So this is a turbidity sensor or meter. And then I mentioned about the environmental data, climatic data, because climate change and water sanitation, they go hand in hand, which is part of the SDG. So this is an example of some of the external sensors we've been introducing under the casing enclosure I just showed you. So this will measure our temperature of the ambient environment and also the humidity. I'll be introducing one to measure also the luminous intensity, the pressure, and even the gas. We'll be introducing some gas sensors that are able to sense how clean the air is, and areas of maybe when there's a situation of possible air pollution, like areas of oil drilling, where there's oil spillage, you can actually sense the hydrocarbon gases and then create an early alert. This is coming, if you can show them over here. So this is actually the signal from the flow meter. This is actually the flow meter that tells us how many liters have been used. So you can see the wire coming from inside. So it's not easily accessible from outside, absolutely. So it's vanderproof. It flows in here into the reservoir before it comes out. So we're able to take the direct temperature of water from here. The same goes with the turbidity meter as well. All this will be mounted somewhere here and they'll be waterproof. So as water is coming out from the borehole, coming in here, we're measuring all those parameters, which is key. Water quality. So the good thing about this very solution or system is that we're able to measure your water quality directly. Tell you how clean your water is, the pH of your water, the temperature of your water as well. And of course, we are gathering some climatic data for monitoring of climate change. Then your pH sensor, which is very important. So that's the pH sensor, you can see it. Very, very sensitive. And it's waterproof, as you can see. It's sealed, this IP65 standard, completely sealed. So it doesn't get into the water. All these will be like sensors hanging all over here. So everything will be easy.